What we mean by equilibrium conditions and non-equilibrium and entropy and negative entropy is not really that complicated, but it's an area where a mystique has grown around it because they really struggled for 100 years to properly express things. Some of them they're still struggling with. But basically, let's start with entropy. What we mean with entropy, it originally was just dissipated potential. That's all it was. And it meant I'm dissipating some energy that the system previously had under its control and could use. It now no longer has that much energy. And all that entropy is a measure of that energy that that's out of your control. Maybe you used it to power the load, or maybe it went out in losses or whatever, but you lost control of it and you can no longer use it. You didn't destroy the energy, it's still out there. But you can't use it anymore in the system. That's all entropy is. It's nothing magic, nothing mystical or anything. It's a measure of the energy the system had and could control and use, but it no longer can do that with it. That's how much it's given up. By the same token, if you want to be consistent, negative entropy would be when you give it some more energy which it can control and which it can use, because now it has additional energy. So its entropy has decreased from what it just was when it had lost all the other and no replenishments. So, but I involved what's called a non-equilibrium condition. I actually opened that system, although they use the term open in a very restricted sense in thermodynamics. I need to change that. But I opened that system and I allowed some energy to freely flow in there and the system to catch it free. Once it gets in there, it doesn't matter who furnished the energy. I furnished it, nature furnished it, the vacuum furnished it, whatever furnished it. As far as the system is concerned, I just reduced my entropy because now I have more energy again under my control. And I just had a negative entropy operation. So negative entropy is not anything mystical either. It's just the acquisition by the system of more energy that it does control and use. That's all it is, a measure of that. If you have a system in equilibrium, it's already sunk as low as it can use any energy. All the energy it could use, it's gotten rid of, and it's the condition of maximum entropy. Look at all the energy I had when I wasn't in equilibrium. Now I've lost all of it. So I don't have any more to lose, maximum entropy. But if I depart from equilibrium, what I mean is I allow this flow now to come in and extra energy exchange that I can grab and use. So I lower the amount that's lost as far as the system is concerned. It now has some extra. So as far as the system is concerned, its entropy decreased. I haven't lost as much now really because I've got all this new replenished. And so I now have it available again. That's all it says. There has been more fuss and fury and raging and absolutism and name calling and everything in the world about entropy and negative entropy. And about 95% of it is foolishness. It's people who haven't looked at what the concept really means and nothing else. Or you just assume equilibrium. Second law, as it's written, assumes the system is in equilibrium. It's already reached maximum entropy stage. So, obviously with that, if it's in equilibrium and nothing else is ever going to come in, the equilibrium is not going to be broke. You're not going to reduce the entropy. It's already lost. So it says it very nicely. It says you can either, the only thing you can do with the entropy is have it increase, or else you can keep it the same. Because you're never allowing anything else to come in. That's all that means. It has no mysticism at all. It's not a magic law of nature that you can't break. Every time you flip a light switch, you violate the second law of thermodynamics. And when you violate the second law, that doesn't mean you violate the first law. You do not violate conservation of energy if something gives you the energy. So if you take that to heart, even from thermodynamics, you go around looking for effects or phenomenology or things that are known that do give you some energy. Well, we did this early on. Sailboat. The wind will give you energy. So you can happily sail your sailboat in total violation of the second law of thermodynamics and sail right on around the world and very simply. A windmill. It's continually receiving energy in a form we well understand, wind. We understand wind because it blows on us all the time. And it'll blow us down if it gets strong enough. So we understand that the windmill continually gets energy into it from its environment because the wind gives it to it. We don't have to pay for it as long as it gets it. And the windmill very happily runs along, violating the heck out of the second law of thermodynamics. It does not violate the first law. Every bit of energy that it gets in, what it wastes and what it actually gives you in the load, is absolutely put into it, but it's put in free by the environment. So many things have been made absolute, which shouldn't be absolute at all. We should go back to the simple meaning, what we're really talking about when we say, I've lost energy control of so much energy. And every real system has losses that's operating and doing things and doing work. It has losses. And you do lose, and you do gain in entropy that way because you lose control of energy. Big deal. All you have to do is see that the energy keeps getting input to it and replenished. And it'll very happily keep replenishing the energy control that it lost, and that's negative entropy. If it's in a steady state condition, it's producing negative energy as fast as it's producing positive energy. If you're drilling in a piece of wood with a drill at a steady rate and doing steady work, you're violating the heck out of the second law. You're doing negative entropy all the time and positive entropy at an equal rate. You have a non-equilibrium steady state condition. There's a special thermodynamics branch just for non-equilibrium systems. So you don't take the thermodynamics of equilibrium systems and start beating people over the head that are using non-equilibrium systems, because it doesn't even apply. So one thing we need to do is for everybody to get straight on the thermodynamics they're talking about and realize that when we're using charges and electromagnetic fields, electromagnetic potentials, we're using flows of energy, and we automatically have a non-equilibrium system. We are permitted to violate the second law of thermodynamics. Take a good textbook in non-equilibrium thermodynamics, Condiputi and Prigogine, Modern Thermodynamics, and they cover everything on down to dissipative systems. You'll find in one area, on page 459 as a matter of fact, you will find they list the areas already known and recognized by thermodynamicists themselves as violating the second law. One of these is very sharp gradients. Just make sharp pulses, sharp gradients. And you mess with the vacuum, you mess with whether the electrons stay in the Dirac holes and all kinds of things, and you involve excess energy inputs to your system, and you can violate permissibly the second law by as simple a thing as sharp pulses. Let's talk about motors and why we don't violate laws like that, and why we don't go over unity, why we don't produce more energy out in a motor than we put in. And let's talk about how to do it, where we will do that. If I have a standard, what's called linear magnetic motor, I'm going to make a very simple one in concept here. Imagine two rails running. Instead of parallel, they diverge just a little bit as they run, and they're about this long. So these rails are not quite parallel, they are diverging just a bit. But the rails are really the north pole heads of a bunch of magnets on each side, north poles facing in. So what I really have is this rail, this gradually spreading gap between actually two long linear north poles. If I stick another north pole in this rail, in this slot, this linear magnetic motor, what will happen is it will develop a thrust, because just ahead of it, there's lead. The north poles are further apart, and there's less north polarity density there than there is here. That looks like a little bitty south pole, and it's a north pole, so it'll get attracted that way. This little car that I put with this little north pole on it, for example, will then accelerate right on through this linear magnetic motor. That's a piece of cake. It's in every electrical engineering set of handbooks and everything else, and plenty of experts on linear motors. Okay, let's say that we want to make that a closed loop system, and we want to make that thing run itself. Suppose I take this rail, this gradually diverging rail of opposing magnets, and I turn it in a circle, and I almost close it, but I leave a little gap. Well, the fact is the rails are diverging just a little bit all the way around, and if I have a rotor, the little car, the little magnet now, the North Pole is on the end of a rotor. The rotor will accelerate all the way around to where this gap is. Continuous acceleration, building up torque, building up angular momentum, everything else, picking up stored energy. Now, however, I have a problem. That's the forward MMF region, magnetomotive force region. This little gap is the back MMF region, where I'm now against the field. So suddenly, if I allow this thing to just go on through the gap, I'll pay back everything I gained, and I'll have some losses in the systems. This system will not run. I could give it a big crank to start, and it would just run right down. And that's it, and stop. Well, I would rather not do that. What makes it stop? What makes it stop is that the back MMF is the same as the forward MMF, and I'm licked before I start. That's Lorentz symmetrical regauging, and I have built a system which, if I leave it like that, will enforce, self-enforce Lorentz symmetrical regauging. I'm never going to get an extra watt out of that system. In fact, I won't quite get out all I put in because it does have some friction in the bearings and it fights the air resistance. So I lose a little bit. It will always be a coefficient of performance less than 1.0. Well, people like Takahashi looked at that and they said, the problem is, suppose I could get rid of this back MMF section. If I could do that, he wasn't saying I would violate Lorentz symmetrical condition, but he would. He would. That's what you would do. And then you could have a self-powering, self-rotating system. Remember, all the energy is coming out of the vacuum through the dipolarities. It isn't coming out of what we put in or anything like that. So what we would do, or what Takahashi did, is he put a pole piece, a little piece of metal like an inverted T with a handle on it sticking up outside that crosses that gap. And he put a little coil on that handle. And he put a little tiny, tiny current just barely going through that coil. Now, he's paying for that. He's paying a little bit, not much current. And as this magnet, which is accelerating around through the rotor, through the forward MMF, as it's just entering this zone, this overlaps that end of the forward MMF a little bit, you sharply break that current that's going into the coil on the inverted T pole piece. What that does is invokes Lenz's law. Fortunately, that one's in the electrical engineering textbook, and so the electrical engineer understands what I'm saying. And momentarily, there is a surge of increase in the current. Now, if you had that arranged so the field that it makes is in opposition to the EMF field, momentarily you have a very strong field, a much stronger field up here, that's stronger than the back MMF, and you convert it to forward MMF. You paid a little for it, but nothing like what you have for just a moment. Sharp gradients, right? Can violate the second law of thermodynamics. That's already proven in non-equilibrium thermodynamics. I don't have to go reprove it. So what happens is the thing accelerates right on through what had just been the back MMF. Now the next instance it's back MMF again, but it's okay. Back MMF doesn't do anything to me if I don't let it affect me, if I don't let it ever be able to influence me. So what I did, I skimmed right by it when it had no effect on me. And in fact, the temporary field that we had made was in fact an accelerating field. I paid a little bit, but I got a motor which overall I gained. And now I'm in COP greater than 1. I have to charge myself for what I feed the coil. Everything else is permanent magnets. But that engine will rotate and produce much more power that you can put a generator on the shaft and so forth than you have to furnish to the trickle charge to your pole piece. And if you use very efficient switching, you've got to be very efficient here, but well within the state of the art. Any electrical engineering department can easily build a COP greater than 1 Takahashi motor. The fact that they do not do so is absolutely inexplicable. Everything we said is in the physics book already.
How known is Takahashi's work?
He's got a patent on it, and so you can go get a copy of the patent. You know, you can find out exactly how he did it in the patent and so forth. And that motor will work, and any electrical engineering department in the United States and any national laboratory can build it.
It's a Japanese patent, isn't it?
It's a Japanese patent, but they also, I think there's a U.S. patent. Part of it is under a U.S. patent. But anyway, this is a unit which could easily be built at our universities, in our national labs and everything, and then settle this argument once and for all. All you got to do is do state-of-the-art efficiency in the switching. Don't try to use too strong a current to begin with. Use a very small trickle current. All you want is that field at that short period of time when you have transit through the back MMF zone. That's all you want.
It's timing.
Timing is everything. You have to pay for the timing and the switching. You don't have to pay for the energy. If there's one law we need to pound in every engineer's head, you have to pay for timing and switching. You don't have to pay for the energy. That's nonsense. The energy comes right straight out of the vacuum for free from all the charges. So that's one engine that we wanted to discuss that could be built by any craft shop, any outfit that builds motors and generators could easily build it with their own staff and workers that they already have. They would have to think a little differently, just a tiny bit differently.
Is that the same as the magnetic Wankel engine?
Yes, that's the magnetic Wankel engine. They actually put that engine one time in a Wankel car.
It just proves the principle that it can fire into the track, see? There's the pole, and then there's, see, that acceleration that takes place in the magnets, like this, see? It goes around there for free, but then comes by and triggers itself again, see? Watch. See it?
Right.
And then down here is a dead spot, see?
Why didn't you run the magnets all the way around?
Because we just wanted to see if it would accelerate through the track.
Okay.
We just wanted to experimentally see that it would run
So by just
and do what they said it would. And it does. Of course, you get much finer with this, right? You get real finer in detail with this and make the pole piece bigger and the magnets closer together, and then the thing would fly. And because it goes now, it's just a model that proves that the theory worked.
and so you just you were satisfied with that, so you just quit.
Well, I could do anything with it. It's a patented item, you know. I can make one,
Right.
but you can't sell them.
That doesn't happen as far now.
I don't know.
When did you build this?
When I put the pages up on the internet, when we were
Right.
96.
96?
Yeah, I wanted to see, you know, I was working with some magnets, and I wanted to see if that track theory worked,
Right.
and it does.
So if you ran the magnets all the way around, it would run.
It would run like the magnetic wrinkle.
Right.
But I didn't want to make it too
You
obvious.
disconnected. Yeah.
Yeah. I didn't want to make it too obvious.
I see. You wanted to stay this side of the patent.
Yeah.
Yeah. Right.
It's not mine, so
Yeah.
I want to stay away from it.
Hitachi had.
Yeah,
Hitachi had. They had a scooter or something.
The reason it's not on the market is because the Japanese Yakuza has suppressed the Japanese engines that are OV Unity off the market, including the Kawai engine, which was suppressed here in Huntsville, Alabama, directly in front of my eyes and directly in front of the people that I work with, my associates here. We have plenty of witnesses as to when Kawai's engine was seized and when control of his company and his fate was seized by the Japanese Yakuza, looking at us across the table. So this is not hearsay. This is something we absolutely experienced ourselves personally, and multiple people did.
Mr. Kawai.
This is the Kawai engine. We had just reached an agreement with Kawai, and Kawai does another trick that switches the back MMF path into a forward MMF. He switches the path. And if you apply the Kawai process to a high-efficiency magnetic motor, for example, a Hitachi motor, you can get one at 0.7 or 0.8 efficiency. The COP will be about double the efficiency. So you'll get 1.4 and 1.6 for your COPs. Again, totally consistent with physics and thermodynamics, nothing magical at all. Had his system and company and everything not been seized, we would have had, that was 96, we would have had Kawai engines worldwide on the market in 1997. And that's what stopped it, and that's what's stopping it today. So there are systems which work. If you wanted to do work on the Kawai engine, it works just like what he put in the patent. if you will carefully do the patent and use state-of-the-art switching, photon-coupled switching, you can build a Kawhi engine, and if you'll start with a high-efficiency motor instead of a low-efficiency motor like we commonly have, you can have a motor that will go over unity. Kawhi already had one with positive feedback to run itself. That's the one we would have put on the market. So that's another one that anybody wants to build something absolutely legitimate. If you will take the time and the trouble and do it state-of-the-art switching, you can do it with the Kawhi motor just as it's stated in the patent. There's nothing false in that patent. Another engine I'd like to talk about is a permanent magnet motor altogether, without any switching or without any trickle currents or anything. Now, let's reason together. If I'm going to violate this second law of thermodynamics, I'm going to have an extra input of energy from the environment. If the only energy going into the system is what I pay to put in, that system is never going over unity, because it's got losses. I'm back in leaky diode engineering. I'll put in some, leak out some along the way, I'll get out less than what I put in. As simple as that. If I'm going over unity and all I have available is leaky diodes, I have to have something else putting in energy. What it turns the diode into a triode. I'm paying for the grid signal and something else is putting in most of the energy. So understand very clearly, we cannot do this unless we receive in these permanent magnets an extra pulse of energy for free from the environment. So how can we do that? All I've got is permanent magnets. Where's the energy going to come from? Well, nature has been most kind. In magnetism, there are some 200 or so known magnetic effects. Well known, in a textbook, in a handbook, you can go look at them. But only about 100 or so of them are well understood. The other 100 vary from somewhat understood to not understood at all. I want that to be clear. Magnetism has many areas that are still not well understood at all. Many times just an ad hoc theory. So, but there are lots and lots of rich effects in magnetism if you dig them out and look at them out of the magnetic materials handbooks. One of these is the exchange force. Go into Feynman's 3 volumes of physics and read what he says about exchange forces, for goodness sake. The magnetic materials themselves can undergo a sudden flip of the spins of the electrons. And that is a sudden magnetic field pulse, because the spins have to do with the magnetic spin in the magnetic field. Isn't that interesting? Long before we had what today we're calling spintronics, where we are actually using these spins and beginning to build semiconductors and things that do spin flipping, people like Howard Johnson and people that doing experiments with the exchange forces were doing it a long time ago. Howard Johnson was working in what today is called spintronics 50 years ago, before that word was ever even born. But he was chasing and getting the spins to flip. So let's build a permanent magnet motor first that won't run itself, and then let's make it into one that will run itself. Wouldn't that be interesting? So what we do, we use the rotor and the stator, and I'm going to use in my rotors, I'm going to use north poles on all the poles that are there. And in my stator, around the outside that's fixed, I'm going to use south poles. So let's take one pair of these poles with the rotor north pole coming into the south pole. Now, I'm in the forward MMF position, am I not? This thing is attracting it in, and so it's adding to the angular momentum of the shaft, and this thing is picking up energy storage all the time, till the poles now actually oppose. Well and good, I got a lot of energy that nature gave me that I didn't have to pay, that's now stored in my system. However, as it continues to rotate, if I don't change anything, I pay back every bit that I gained, because I entered the back MMF where it's trying to pull it back in the other rotation direction. And it subtracts back all of the energy it gave me for storage. I pay back everything. And since I got some other losses from the bearing frictions and fighting the wind, the air, to actually turn in it against the wind, against the force, I have losses. So this system will not self-rotate. I can give it a big spin to begin with, and it'll flip around a few times, and it'll run down, and it'll stop. That's it. Well known, no problem. So what's new? And what's wrong with that? How am I going to make that self-rotate, taking its energy from the vacuum? Well, I've got to follow my basic principle. If I want that to self-rotate, I'm going to have something which injects some extra energy. And if it's pulse form, that's better, because that gets under the thermodynamics that's known to violate the second law, already accepted. So I need some pulse inputs, a powerful pulse, to get a good bit of energy in that thing so I can have enough left to overcome my wind resistance I'm paying for and my friction and my bearings. Can I do that? Yes, indeed. The exchange force will do that for you. What Howard Johnson did was find complex assemblies of magnets, little magnets that he cut in special forms and shapes and all of this. And over years, he found how to put together sets of these, so that just as he has a rotor magnet passing the stator magnet in attractive mode, just as it enters that back MMF mode where it's payback time, the stator magnet will suddenly, the materials themselves will suddenly generate a spin flip the spins, and that will generate a very powerful pulse. And you've got to get it in the direction you want it on the other magnet so that it adds to the rotation. So it's tricky to do that, and it took him a long time to discover just how to do that, and just how to cut those magnets, and just what kind of magnets, and all of that. But he eventually solved the problem of how to do that. Now, if you will check Feynman's 3 volumes, you will find that this sudden force that occurs for the exchange force can be hundreds of times stronger than the magnetic fields and the magnets you're using, momentarily. But it can be a very powerful pulse. Johnson developed a series of magnetic gates and rotors passing stators and so forth, where the exchange force is in fact evoked. The pulse goes in, you get enough of it in the right direction to kill again the back MMF section, overcome it, and produce a forward MMF section. You need it just for a little bit till you get out of the back MMF. Then you're okay. Because if my back MMF is now decreased, less than my forward MMF, and if I don't lose too much losses in my system, that system will power itself and self-rotate and power load. And that's true. And you didn't violate a single law of physics, and you did not violate thermodynamics once you include the broken symmetry of the dipole and where the energy is coming from.
Now, does that pulse have an electrical switcher on it, or is it all just...
No, it's just the electrons themselves that are making the magnetism just suddenly flip. And that's the spin of the electron flips, and that's a tremendous pulse when it does.
So the timing is also...
Timing is critical. The timing is what is the most critical thing on it. And everything physically that you do to this assemblies of magnets affects that timing. That is, what the material is made of, exactly the shapes that you put together, it's going to determine which way the pulse goes, and getting it to occur at exactly that right time. See, he's doing it all mechanically. He doesn't have any switching.
There's no electronics.
It's the assembly that determines the switching. So that's very precise work and very intricate work to do that. But it's a doable. It is certainly a doable. But you've got to be very precise and have good machine precision in the way you make your magnets, and you got to pay the penalty to find out how to do all that. But once you evoke the exchange force by whatever means, you can use spintronics to do it now. By whatever means you evoke the exchange force, you can in fact have the materials themselves take from the vacuum extra energy and give you a tremendous pulse of energy that adds that energy you need to your system and overcomes that back MMF. And that system will then permissively power itself and power load, take any energy from the vacuum by its fundamental dipolarity, its fundamental broken symmetry in that vacuum flux. Everything is good physics. There's no hokum, there's no sleight of hand, there's no magician's trick or anything. There's pure science behind it. Doesn't mean it's easy in that case, but it can be done.
You could essentially build the equivalent of a hydroelectric dam.
That's correct.
In the middle of a desert.
That's correct.
Because it's all magnetics.
That's right.
You don't need any external power. You don't need, it's all timing and natural magnetic forces.
That's right. Many years ago, when Howard first made his first rotary engine, Howard brought it down to Huntsville to show me. That was in the 70s. And we sat in my kitchen, and I played with this thing for 2 or 3 hours, just fascinated by it. There wasn't anything in it but permanent magnets, and it just sat there and it kerclonkety. It was part of it was crudely made. It just went kerclonkety, 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 and it kept right on going. Now, if something will run 2 hours, kerclonkety, kerclonkety, and there's nothing in it but permanent magnets, and it's got that much drag, the bearings weren't even good. He was using an old Lazy Susan, which poor bearings. It wasn't precision bearings at all. He just grabbed something and put the magnets he found that would work on. So there was no question about the reality of it. The question then was, how do you explain it? But Johnson knew about the exchange force. He knew exactly what he was trying to do. So Johnson was on, in fact, the proper scientific track that is permitted to build a self-rotating, self-powering magnetic engine. Permanent magnets only.
Did he learn this from observation?
Johnson started working in magnets. See, Johnson's in his 80s right now. As a young engineer and everything, he used to work for, I believe it was Chrysler. He did the magnetic brakes for Chrysler way back there. Johnson did some very unique things. He was a specialist in silencers, for example. There's a lot of patents in silencers back there.
For guns?
How to silence things that make racket. Johnson silenced a locomotive one time. Cut that noise way down to where if you were a certain distance from it, you didn't hear the locomotive. He could silence a chainsaw pretty good. Things like that. So he had some very unique things he had to do in his engineering experience. But he was a specialist in that kind of thing, and he started off working in the magnetics. He read up everything that he could find about the effects in magnetic materials. So Johnson got on to the spin and spin flipping very early, when very few people knew about it at all. It was an idle curiosity in a few lines in the text somewhere. We didn't have what today is trying to be born as spintronics. Now we're trying to create a whole science based on just spin flipping. Johnson has been working in spin flipping for 50 years. Very fine individual, I might add. He's a very fine human being. I'm very proud of the fact and very grateful that I was permitted to work with Johnson and have been for many years, still working with him today. I got into this kind of thing because first was an interest in strange weapons that I ran into the Soviets were building when I was working in that area. And then that led me into energy, because the problem that we ran into with trying to figure out what these Soviet weapons were, they were not using normal electrical engineering. They had modified it into a science they called energetics, which was highly classified, and they never have released it really to this day. What they really did is correct all the errors in the model. And when you do that, you can do all kinds of things that we've discussed a little bit that you can't do with normal, much more limited electrical engineering. So they were able to build very special weapons using that. But it has beautiful applications in medical and in energy fields. So, you know, it's a perfectly legitimate science if we take the old electrical models we have and change them and update them with what we've learned from physics. We will have then what the Soviets have been, the Russians today have been calling energetics for a long time. And we can do some marvelously beneficial things for human beings with that. One of it is in the energy field, and the other particularly is in the medical field. So that got me into the energy field. And then I started working with inventors. I started working early on with Frank Golden, and we talked about building the motor that kept adapting its environment and gradually got up over unity. And we didn't understand the mechanism going on at all, but it did get up to the performance, rigorous measurements. So that was very interesting. But again, I was fortunate to be able to work with an inventor who was actually inventing things like that. I showed Frank one day. Frank did another thing. He was, since Professor William Tiller, former head of the Material Sciences Department at Stanford, was also connected with that project with what was formed then as Astron Corporation. Professor Tiller knew a great deal about the magnetic vector potential A, which of course we didn't. And Frank thought so much of that that he decided he would build some A potential antennas, which he did. It was interesting because the CB radio was just coming into vogue, and all the truck drivers had them. You know, they started the vogue because they were chatting to each other and all. And Frank would take a CB radio and hook up his special magnetic vector potential antenna, and the little radio that's supposed to give you about a mile down the road would knock their socks off about 20 miles down the road. And these truck drivers would say, "Man, what have you got? What kind of rig have you got there?" You know. But we knew we were onto something when the antenna performed so admirably. But Frank did build a whole series of special antennas, which some of those, plus some other modifications to them, Astron markets to this day. Astron Corporation still exists. I still own some stock in it. But I was fortunate to be able to work with Frank, because here I was able to work with an inventor where phenomenology was occurring. I was able to see some of the phenomenology and then have to figure out what on earth is going on here. So in the injection of some real good science from Bill Tiller was nice too, because that put our feet in the proper scientific direction rather than wandering off and trying to form a lexicon of our own. We found out this stuff is really in physics, you know, if you know where to look, if you look long enough.
And that is carried through to this day.
That's right. So another thing, I was very fortunate to work with several other inventors that we've named, you know, such as Floyd Sweet, 2 or 3 others along the way, particularly John Bedini. I work with John today and have worked with him for many years. John, as far as I'm concerned, is probably the single most creative inventor on this planet. And he is what I consider a national asset of inestimable value for what he's already done.